And the reason it has ice there is because Mercury is a heavily cratered surface. And so craters in the polar regions, the inside of them, are constantly in shadow.
That's because Mercury is vertical relative to the plane of its orbit. So some crater floors never receive light or heat from the sun. But with no obvious water source on the planet, that begs the question, how did the ice get there? Scientists believe the mystery ice could have come from a comet. Comprised of rock, dust, gases, and ice, comets come from the outer reaches of the solar system, where the temperatures are much colder.
Could this ice just be on the bottom of permanently shaded craters, or could it be ice that's sort of covered up by a layer of dust which is shielding it from sunlight? We really don't know.
Besides these comet collisions, there is yet another type of crater on the planet, and they weren't formed by anything that fell from the sky. Instead, an Earth-like force of nature created these holes, and it generated deep from within the planet's core. Mercury. A closer look at it. With Mercury cinder cones.
Because Mercury has less gravity, we would expect the cinder cones that form to be much wider and much flatter.
All volcanoes erupt when the pressure from the magma, or molten rock inside, is greater than the strength of the rock containing it. Pressure increases for two reasons: too much magma and too much gas. And when pressure increases in a volcano, it usually has one place to go.
Lava comes up to the surface and erupts explosively. You have a vent area, and you have what's called a fire fountain.
If the pressure is great enough, its force can spew lava higher than 100 feet on Earth. But on Mercury, with such low gravity, the fountain could eject lava 30 stories high. While these cinder cones in Arizona may illustrate our shared volcanic heritage with Mercury, to witness an eruption there firsthand and watch the cinder cones form would be a whole other experience. First, without an atmosphere, a plume of ash and smoke and debris wouldn't billow across the landscape.
That material would go into essentially a vacuum of space because Mercury doesn't have an atmosphere, so that material would break up much more.
Also on Mercury, you wouldn't be able to hear the loud eruption.
Since Mercury has no atmosphere, there's no way of transmitting sound. So if you were on Mercury and playing a guitar or a ukulele or a piano, you would not hear anything because there is no atmosphere to transmit that sound. So it would be just complete silence.
Back in 1974, Mariner 10 surveyed only 45% of Mercury's surface on a flyby mission. 30 years later, NASA launched the Messenger spacecraft. The satellite will map the entire planet and transmit data to eager scientists with a deluge of unanswered questions.
I want to see the other side. I don't know what's over there, and that's been bugging me for 35 years. Is it like the side we saw, or is there something very unusual and different?
But even with resources being earmarked for future exploration of this rumpled dwarf in the solar system, exactly how different or similar we really are may be left up in the air. Despite the harsh conditions on Mercury and on Venus, a close look around our own backyards reveals the good, the bad, and the ugly of the inner planets.
The universe is this vast, vast thing, and here we are sitting on this little pinprick. I mean, we are not isolated.
We see things that happen on these other planets for tremendous climatic changes in the past that have happened in a very short period of time and changed that. And that can happen on the Earth.
Ultimately, it enriches our knowledge of who we are and how unique and how rare an environment like ours and even creatures like us might be in the universe.
And that evolution, that exploration, that turning the corner, that discovery of new ideas is what we're all about. There's a bright future.